an explanation. Right, let's take one more example. Okay, so I'm going to take one more example here. I have this x squared minus 2x minus 5 equals to 0. Now, we have this also, and this cannot be factored as well. For example, if you want to factorize this, we have the coefficient of x squared to be 1. 1 times 5 is going to give us 5. Now, the factors of 5, what factors of 5 can we multiply to give us a minus 5? All right, we have 5 and 1. 5, just 5 and 1. Okay, if I say minus 5 times 1 can give you a minus 5. Then, what factors of 5 can I add to give me a minus 2? None. There is no factor of 5 I can add together to give me a minus 2. So this is why this particular equation cannot be factorized. All right, this is why it cannot be what? It cannot be factorized. So in that case, in such equations, completing the square method comes in handy. So in that case, we're going to go ahead and look at this and solve this using the completing the square method, similar to the method we applied the other time. So we're going to have it that x squared minus 2x will be equals to, I'm taking to my minus 5 to the other side, and it becomes a positive 5. I'm going to add half the square of the coefficient of x to both sides. It's going to be x squared minus 2x plus 1 squared equals to 5 plus 1. Okay, so I'm going to have it that x squared minus 2x plus 1 squared equals to 6. All right, so now we have it that I'm taking the perfect squares now. All right, it's going to be x plus 1, right, all squared equals to 6. Then it's now going to be x plus 1 equals to square root of 6 if I decide to take the root of both sides. So if I'm taking the root of both sides, the square root here will cancel the square root sign. So that's exactly what I did, and I decided to bring it down. So I'm having this bracket, I having x plus 1, so I brought this down, then I brought down my 6 as well. All right, so I can now go ahead and subtract 1 from both sides because I'm looking for my roots. In that case, I'm going to have it that x will be equals to minus 1 plus minus root 6, right? Plus minus root 6. So now I'm going to bring it over to this side of the board, which is going to give me minus 1 plus or minus root 6. So my roots now are going to be minus 1 plus root 6, or I'm going to have minus 1 minus root 6. So those are going to be my roots, the roots of this equation. Yes. So the essence of this lesson this evening is to make it, first of all, is to give you an idea of why we're employing the methodology of completing the square method. We need to also, I want to help you understand that some equations, quadratic equations, are not factorizable. And that doesn't mean that you cannot solve them. All right, so these are just the reason. Now, completing the square method is also very powerful because it is from the completing the square method we are able to what? To form the next method, the general formula use, the general quadratic formula that we normally use to start, to solve most problems in quadratic equation. That's the almighty formula. So in the next class, in my next video, I'm going to make a video of how we can use the completing the square method to derive the general quadratic formula. All right, so I want you to stick with us. Just hit the like button.